And welcome back to this video. Here we'll be learning how to calculate the gradient of tangent lines and normal lines and their equation of those straight lines with the derivatives. So let's go back to basics first of all. Let's see what did we do if equation we had to find the equation of tangent and normal of y equals to x squared at point x equals to 3. We know how to use the derivative here. We evaluate, maybe I should have hidden this first of all. First we say dy by dx equals to 2x and we evaluate this at x equals to 3. The derivative function will tell us 2 times 3 is 6. Therefore, the gradient of tangent here is 6. This is We're going to put that into equation of a straight line here and use the point where y is x squared, 3 squared is 9. So this is the coordinate 3, comma 9. So we're going to calculate, this 3 is there, and that 9 is going here into the equation of straight line. If you don't remember, y minus y1 equals to m times x minus x1. We substituting the coordinates and the gradient into that equation. So that will tell us the final equation of the tangent. Notice the tangent of to the curve at that point is minus 18 plus 9 is minus 9. Okay, so finally now we are going to look at normal. If you don't remember what normal is, normal, okay, you haven't heard of the word normal, because in when we did gradients of perpendicular bisectors, we just used the word perpendicular. So the normal is a line that is perpendicular to tangent at any point. All right. So normal normal line is perpendicular to the tangent. So what it means is that you're going to use the factor perpendicularity. So remember m1 was minus 1 over m2. That business had to find perpendicular gradients. This is exactly what you're doing. The normal is just a new word here. What the concept is the same. The concept is to use the perpendicular gradient. So we went through the trouble of calculating the gradient there. So we found n1 was 6. Therefore, what is the gradient of perpendicular line is minus 1 over 6. So when we calculating the equation of this line here, this graph, this is x squared, by the way, if you will notice, there is a graph there, and normal here is this line that is crossing the curve. Look, notice it's crossing the curve, not tangent to it. Okay, so make a note of this if you wish. And finally, we're just gonna put y, and we still using the same points, the same coordinates. So y equals to negative 6, open a bracket, and write minus 3 here, and work this out. What's the multiplication of the bracket is negative 6 1 times x, and we'll have a plus 3 over 6, which is a half, and then I'm just going to bring that 9 and write it next to a half. So y will be minus 6x plus 9 and a half. 9 and a half, you can write it as a fraction as 19 over 2. Okay, so this is in short how you figure out the equation of a tangent and equation of perpendicular. we're gonna look at some more examples. So in your book, you might see this kind of a formula here where you have f dash. Okay, I don't think that's necessary because we know m is calculated by evaluating f dash at the point where we are told x equals to a. Alright, so because they're using x in the formula, they're using x1. Alright, so okay, so this is exactly saying what I just wrote on the previous slide. This is y naught or y1, doesn't matter what the subscript is, and this is our gradient, and this is x minus like x naught here. Okay, so this x and y, this one I'm writing in bold, is part of the formula. This y, that x, but you replace these with the coordinates. Y naught and x naught are coordinates that come from there. Here is all written there anyway. So now, so we said that that's the tangent and the normal. The equation is written like so, but you know that this is the definition of the perpendicular gradient, minus 1 over the original gradient. So if I don't think it's necessary to complicate things with, but I was just going to show you that if you see this in your book, this is exactly what we were doing on the previous slide anyway. So that shouldn't be a surprise to you. So this is just m2 times x minus x naught. Alright, so let's use it and solve some problems with it. We've been told to find the equation of the tangent to this curve at point 3, comma 5. Alright, so notice one more time that 5 is irrelevant to us. We just concerned with x coordinate. So tangent, that means just go ahead and find dy by dx. So pause the video, do this with me. So tell me, I hope you've seen 3x squared minus 6x plus 2. Then we're going to evaluate this expression at x equals to 3, and we're going to get 3 times 3 squared minus 6 times 3 plus 2. So this is going to tell us that the gradient of tangent is 27 minus 18 plus 2. So 29 minus 18 is 11. So now we know m. Okay, this is the gradient of tangent. What is the, actually we do need that 5, my bad. So why was I crossing it off earlier? I don't know. We need that point to substitute into this equation, remember? So always write what the equation is before you substitute into it. Alright, because this will help you put the numbers in the right place with the right sign. Most students don't bother writing the equation and get the signs wrong. So we're going to write y minus 5 because they've already evaluated that and found that 3 cubed minus 3 times 3 squared plus 2 times 3 minus 1 is 5. We weren't told that 5, you could have found it there, so we're just using it. X minus, what is our x naught? 3. So then this will give us 11x minus 33 plus a 5 equals to y. So finally, equation of tangent is 11x minus 28, I believe. Yes. Okay, so let's see if I'm right or wrong, and I am almost always right. So the tangent has that equation there. So in this next example, we've been told to find the equation of normal. So exam questions don't underline anything for you, but we're just uh, concerned with normal, and just to point out that this means the perpendicular to the tangent at point x equals to 4. So first of all, we need to figure out the gradient function. So we write dy by dx. There's nothing wrong with writing f dash of x, but since we got y. So first of all, if you might be better to rewrite that with power of x explicitly written as a half first, so that we don't make any errors. We have a constant at the front, that constant disappears, and then we get to do the power rule on this term here. Don't forget the minus sign belongs to this term, not the 8 that disappeared, so we got a negative 3 over 2 x to the power of minus a half. We can evaluate that at x equals to 4, and we'll have negative 3 over 2, and I'm gonna put the square root in the denominator because the power of a half is minus, and this means that negative 3 over 4, because 2 times 2 is a 4. So this is m1. Notice this is the gradient of tangent. Okay, so we want the gradient of normal, which is perpendicular to the tangent. Therefore, it would be negative 1 divided by negative 3 over 4, which will give us 4 over 3. So the equation of the normal is going to be coming from this line here. So we're going to substitute y value, which we still don't have, so we have to calculate the y value ourselves. We're going to say 8 minus 3 square root of 4. So this is telling us what's this y naught really, and square root of 4 is a 2, so 3 times 2 is 6, 8 minus 6 is a 2, and therefore now we can write y minus 2 equals to m2 was 4 over 3, and x minus x naught here is a 4, so we have to multiply the bracket and just tidy things up a little bit. So 4/3 of an x, 4 times 4 is 16 over 3, and when we add the 2 means adding 6 over 3. So then finally we can write this as y equals 4x, 4 over 3x, and we will have a minus 10 over 3. We can even factor a third out and write this as 1/3 times 4x minus 10. Alright, so final answer could be written as 1/3 of 4x minus 10. Okay, so let's see if there is another example.